All right, so let's take a look at our warm-up for Monday, February 12th. Number one says negative 16 plus 8. What is the answer for negative 16 plus 8? Jared? Negative 8. The signs are different, so you subtract. 16 minus 8 is 8, and then you take the sign of the integer with the greatest absolute value, which is negative 16, so negative 8. 2. Negative 4 times negative 2 times negative 8 squared. All right, first thing we do, what's the first thing we do? Exponents. Negative 8 times negative 8 is positive 64. And now I have multiply, multiply, multiply. Now what? From left to negative 4 times negative 2 is 8. And 8 times 64. 48, 49, 50, 51. 512. 512. All right, number 3. Negative 24 plus 25 plus negative 25. Now, what's interesting about these second two numbers? They are the same number? So they're opposites, or they make a zero pair. They go away. What's your answer? But I thought you had to add left to right. Not when it's all addition. What property says I can change the order and the answer doesn't change? The commutative property says I can add in any order and my answer stays the same. Now, if I had addition and subtraction, order does matter. But if it's all addition, order does not matter. 4. Negative 6a times 2b plus 5c. Now, what property do we need to do here? Distributive. Negative 6a times a positive 2b is negative 12ab. Multiply negative 6 times positive 5c. So I'm either going to get plus negative 30c, or it could say negative 12ab minus 30. Oh, not c, ac, right? ac, ac. Those mean exactly the same thing, right? Plus and negative is the same thing as subtraction. Whoever is hitting their desk with something repeatedly and other people keep saying, please stop, and then you keep doing it. Look, I don't want to argue. I just want it to stop, please. Like, right. Yes, you were. Look, we don't have to air our dirty laundry while we're being recorded and all argue with each other. We can just say, yes, ma'am, and stop. We don't need everyone on the YouTube world hearing that we are going to argue about everything. We were airing our dirty laundry.
Yes, ma'am. Yes, ma'am.
Thank you. All right. All right. The second part of that says what property? We already said that is the distributive property. All right, let's get to number 5, these dividing fraction problems. Number 5 says negative 5 2/7 divided by negative 2 1/7. Let's just go ahead and deal with the negatives so we can stop thinking about them. What is a negative divided by a negative? So we're going to get a positive answer. Now we can quit thinking about it. All right. What do we need to do to be able to divide? We need to change this to an improper fraction. All right, so what do we need to do here? Turn this into an improper fraction. How do we do that? 7 times 5 is 35, plus 2 is 37 sevenths. And remember, I've already dealt with those negatives, so I don't have to bring those down. Divided by 7 times 2 is 14, plus 1 is 15. 15 sevenths. Now, to divide a fraction, you keep, use the reciprocal, which is multiplication, and use the reciprocal, which is 7/15. Excuse me. I can cross simplify. 7 and 7. 7 divided by 7 is 1 and 1. So now multiply. 37 times 1 is 37. 1 times 15 is 15. Can I leave it improper like that? No. So I'm going to say 37 divided by 15. So your answer is 2 7/15. Can that be simplified? It can?
No.
7 is prime. And does it go into 15? No. So your answer is a positive 2 7/15. All right. Any questions about that one? Okay, let's look at number 6. Negative 2/3 plus 1/6 plus 3/4. All right, so you start inside the parentheses first. But what do I need to do before I can add or subtract fractions? Got to find a common denominator for 3, 6, and 4. What do I want to be my common denominator for 3, 6, and 4? 12. So this 2/3 equals how many 12ths? 2/3 equals how many 12ths? So that's times 4. So this is times 4. So I get 8/12, negative 8/12, plus 1/6 equals how many 12ths? 2/12, plus now 3/4 equals how many 12ths? So that's times 3, so 9/12. Okay, so now I have common denominators. Negative 8/12 plus 2/12. So I can think about it as 8 negative 1/12. 1, 2, 3, 4, 5, 6, 7, 8. And then what do I have? I have 2 positive 1/12. Now what? Cross off 0 pairs. And I have negative 6/12 plus 9/12. So now if I put 9 positive 1/12, what do I have left? Anybody know? 3/12. And are they positive or negative? Positive. This one has the greatest absolute value and it's positive. And does 3/12 simplify? What does it simplify to? 1/4. Your answer is 1/4. Questions on that warm-up? Okay, so let's take a look. Tomorrow, you have 2 different sections of your warm-up. This section up here, you cannot use the calculator. This section down here, once you show me those 4, then you can get a calculator for solving these down here. All right? And then Wednesday you do this, and Thursday you'll take your quiz. Does anybody know why I combined these 2?
Because we don't have school
We don't have school on Friday. So this is Tuesday, Wednesday, Thursday. You'll turn that in for a grade. All right, so let's take a look at our foldable for today, the purple foldable. Let's take a look at it, please. Shh, please stop all of your little sidebar conversations. All right, so we looked at surface area last year in 6th grade. And actually in 6th grade, if you were in my class, we worked a lot on surface area. And we did several different activities, and we worked really, really hard to understand surface area. So can anybody tell me what surface area is or how you find it, what you remember about it? Anybody? Anybody? So it has to do with area. Mackenzie? Okay, so what we're going to do, that's kind of what we're going to do. What we're going to do, if you remember last year, we had boxes. You have to find the area of each side. So if I found the area of this, say this is 2 inches by 3 inches, 2 times 3 is 6. So this side would be 6. So what would be the area of the back side? 6. And so if this was 1 times 3, 1 times 3 is, so this would be 3, and this one would be 3. And if this is 1 times 2, this would be 2, this would be 2, and then we add them all up. That's the surface area. The area of all of the surfaces on the box. Do you remember it now? Like we did nets last year, and we were taping things together, and we hung them on the wall. We did a lot of work with surface area. We did several with surface area. It's hard. So what you're going to find, I think, is that it's not quite as difficult to understand this year because we did a lot of work with it last year. But what's different? Last year we just did rectangular prisms. This year we have some triangular prisms. We have triangular prisms. So it's really not that different. These have how many sides? 6. Top, bottom, front, back, left, right. Top, bottom, front, back, left, right. These have how many sides? 1, 2, 2 bases, and then 1, 2, 3 sides. So 5 sides. 2 bases, and then 5 sides. This is the right side, the bottom, and then this left side. So these only have 5. It's because here you have 4 sides, so you have to have 4 sides going between the 2 bases. Here triangles only have 3 sides, so you only have to have 3 faces to connect the 2 bases. And then what's going to be different when we find the area of these triangles? So that's not a circle, that's a triangle. How do we find the area of a triangle, Jesse? 1/2 base times height. So we have to make sure that we use the right formula for triangles. All right, so we're going to just go ahead and jump right in right here to example 1. This is where the colored highlighters are going to come into play. So go ahead and list your 6 sides. And remember, I list like 1 and 2 together because they're going to be the same. So I'm going to say side 1 and side 2. I'm going to do those together because those will be the same. Side 3 and side 4. And then side 5 and side 6. You don't have to list it like that, but it just makes it easier on me to see that I know that 2 of them are the same. All right, let's start with the bottom. What are the dimensions of the bottom or the base of this shape? 5 times 6. So 5 times 6 equals 30 inches squared. And if that's the bottom, that's the same for this top. 5 times 6 equals 30 inches squared. All right. Now what do you want to do? Front and back or left and right? Left and right. So here we go. All right, looking at this side, what are we going to multiply together for this side? The base is 5 and the height is 12. 5 times 12. Yep. 60 inches squared and 60 inches squared. Pick your third color. And now we need to do the front and back. So look at this part right here looking at you. So the base is pretty easy. It's right here. It's 6. What's this height right here? 12. We got to look at that line, and that line will be the same. So 6 times 12. And 6 times 12 is 72. And now what? Add them up. 30 plus 30 plus 60 plus 60 plus 72 plus 72. And we get 324 inches squared. Make sure that it's inches squared because we're multiplying two dimensions together. We'll pause right here and we'll let the ladies go ahead and get their calculators. Ready to start with this rectangular prism? Okay, so let's look at the flat part that is what it is resting on or what it's sitting on. Let's look at the bottom, this flat part. So we've got our 6 sides listed. Let's try to figure out the dimensions of this flat part right here. What are we going to multiply together? 9 times 7. And 9 times 7 is 63 meters squared. And so if that's what the bottom is, that's what this top part is. 9 times 7 equals 63 meters squared. All right, now let's do the left and right side. So I'm going to look at this side right here. 7 times 3. The base is 7 and the height is 3. 7 times 3. 21 meters squared. All right, now what are we missing? Front and back. So it's this right here. So the 9's pretty easy, but what's the height here? 7. No, right here. Right here. 3. There's not an 8 on there. 3. So if the height here is 3, then the height here is 3. 9 times 3 is 27 meters squared. Add them up. What do we get when we add them up? 222 meters squared. Is that coming back to you? You remember that from 6th grade? Doesn't seem as difficult this year as it did last year. Last year we really struggled with it, but usually if we work really hard on it in 6th grade and then we let some time pass and we go back to it in 7th grade, for some reason it's usually a lot easier. All right, so now we're going to introduce triangular prisms. We did not do triangular prisms last year, but it's the same. So we've got 2 bases and they're both triangles. So a triangle for side 1 and a triangle for side 2. That just helps me keep my thinking straight, that I need a different formula when it's a triangle. And then I've got 3 more sides. Side 3, side 4, and side 5. And then those are rectangles. All right, so I've really got to look and try to see my dimensions here. So we've got to be careful that, remember, the height of a triangle goes straight from the base to the top point. So the height of this triangle is 12. Let's be careful with the base. This is the base right here. The height goes from the base. So how am I going to figure out what this is? I've got to look down here. What is this? 10. So this one is 10. So it's 1/2 of 12 times 10. 1/2 of 12 times 10. And 12 times 10 is 120. And half of 120 is 60. Or I could say half of 12 is 6. And 6 times 10 is 60. That's fine too. All right, so if that one is 60, then this bottom one is also 60. 1/2 of 12 times 10. That one's also 60 feet squared. All right. Now we've got to look at 3 different sides down here. So let's look at this right side. What are the dimensions? 10 times 20. 10 times 20. And that equals 200 feet. All right, now I've got to be careful here. This left side is 13 times, how tall is it? No, remember that 12 goes to that. No, how tall is this side? That side's 20, so this side is 20. So 13 times 20. That's 260 feet. And then we've got one more side back there in the back. Let me pick a color I haven't used yet. So this back here. How am I going to see how wide that is? I'm going to look here. Do you see how that's 13? That one's 13. And what's the height of this back part right here? No. 20. So that one is also 13 times 20. That 12 only came into play one time as part of that triangle. It is not any part of any of those rectangles. 260 feet squared. Now what do we do? Add. What do we get? Nope, it's not over 1,000. 840 feet. $840 feet squared. All right, so let's list our sides on the next one, and then I'm going to give you a minute to try to get started on your own on this last one. So, how many bases? 2 bases that are both triangles. So, side 1 and a triangle for side 2. And then 3 rectangular bases. Side 3, side 4, side 5. So I'm going to give you a minute to get started and try this on your own. Make sure you're writing in pencil over here. Make sure you're writing down what you're multiplying together, and then we'll do it together in about 2 minutes. But I'm going to let you get started on your own and try and figure it out. 2 minutes. Let's talk about the triangular bases first. So let's look at these triangles and see if we can figure out the dimensions. What's the base of the triangle? 8. What's this height? It's 3 because back here it's 3. So side 1 and 2 is 1/2 of 8 times 3. 1/2 of 8 times 3. Half of 8 is 4, and 4 times 3 is 12. So 12 centimeters squared. 1/2 of 8 times 3. 12 centimeters squared. Everybody good there? No questions? Commutative property says that's okay. But did you take half of it then? Okay, then you got the same answer. Then I'm not sure why we're talking about it. All right. Let's look at, I want to look at this left side right here. So the base right here is 15, and the height right here is 5. 15 times 5. 15 times 5. 15 times 5 is 75 centimeters squared. All right, let's look at the bottom. So I have 8 here, and I have 15. 8 times 15. Why? If this right here is 8. Oh, okay. So it is 120. Last one that we have to look at is, let's see, what color have I not used? Green. So it's over here, 5, and this one is 15. 15 times 5. And so that is another 75. And so when I add that all up, you get 294 centimeters squared. Yes? Mm-hmm. Yeah, because you could have measured them in any order, right? You could have looked at them in any order. That doesn't matter. All right, so this is going to go on page 101. Make sure you write surface area at the top of 101 and glue it on. So page 101 is surface area. And then I'll show you the table of content in just a minute so you can make sure yours is up to date. I don't do it. We are running out of glue, so borrow your neighbors. I need to order some more glue. Or feel free to bring some glue sticks in if you like. Well, then you'll have to take care of your journal later. Glue it onto 101. Catch your table of content up. And then we're going to look at the skills practice together. We're going to look at 1 and 8 together. All right, so let's look at our skills practice. Okay, so if we start here, if we start with the blue where it's facing us, what are the dimensions if this is facing us? 12 times 7. Now, I would assume that you don't have enough room to do all your math here. So I did my math on a separate sheet of paper. I do expect to see the numbers that you are multiplying together to get your answer. Don't tell me your calculator did it. Your calculator did not do it until you told it the numbers. All right, so this first one I did 12 times 7 2 times. 12 times 7. Then we're going to go over here to the right side. Over here where I have pink, what two numbers are we multiplying together? 6. And what's this height right here? I've got to look here. 7. Oh, I skipped. 6 times 7 and 6 times 7. And then the last one is the bottom. Right here. 12 times 6. 12 times 6 and 12 times 6. And when you add those all up, you get 396 centimeters squared. And then when you're done with that, I want you to look at number 8. Number 8 looks a little bit different than any of the others we've done, and I want you to look and see if you can see why it's different. We're going to talk about it in 30 seconds. Go ahead and look at number 8 and see if you can see why it's different. Is there anybody still working on number 1? Okay. All right, so number 8. Let me see if I can. So what does this say right here? Area of the base. They already found the area of the base for you. You don't have to do anything on those triangles except for write down the area of that base is what? 8.8. 8 8/10. That's all you write down for the two bases. So side 1 and side 2, it did the work for you. 8 8/10. You don't have to do the math. It's telling you what the answer is. Now we have 3 more sides. Side 3, side 4, and side 5. All right, let's start with this one right here that I did in purple. So this times this, what are those two numbers? 4 and 5/10 times 4 and 1/10. $18 and, is it 45 hundredths? 18 and 45 hundredths centimeters squared. All right, let's look at the bottom. 4 and 5/10 times, to go up this way, 4 and 1/10. It's the same. 4 and 5/10 times 4 and 1/10, then you get 18 and 45 hundredths centimeters squared. All right, the last one is this left side. So what's this base? 4 and 5/10. And this height right here, it's the same as this one over here. So that is exactly the same size as well. And then how do we find our answer? Add 8 8/10 plus 8 8/10 plus 18 and 45 hundredths, 18 and 45 hundredths, 18 and 45 hundredths. We're rounding to the nearest tenth. 72 and 95 hundredths centimeters squared. Is that rounded to the nearest tenth? No, that tells that to go up to a 10. And so that would tell that to go up to a 3, 73 centimeters squared. If this was not a 9, we would just be rounding to that place. But you can't change that to a 10, right? That would put a 0 here and you'd carry the 1 over. So that answer is 73 centimeters squared. All right, so your assignment today is to finish the other 9 problems on the front of this. Just the other 9 problems on the front. Do not skip the word problems. Y'all like to skip those all the time. You at least need to try them. Even if you don't have them right, you need to show that you've given it an effort. Any questions? We got 5 minutes. You can get started.